In today's note, we're going to look at some applications of similar triangles. So we're still using the same idea as similar triangles before. If you want a refresher, you can go back and look at the note. But the main thing from similar triangles is that one, all angles are the same. And two, the ratio or the division of corresponding or matching sides is equal. So basically it's all the same. So if I divide two matching sides, it's going to be the same answer as if I divide another set of matching sides. So in example 1, we have a tree casts a shadow of 18 meters. A person casts a shadow of 3.5 meters. The height of the person is 1.75 meters. What is the height of the tree? So assuming that they're standing in the same spot, it's creating the same angle, or the sun's in the same spot, creating the same angles and everything with the shadows. And we're assuming that these two triangles are similar. We want to use this idea to help us find the height of the tree. So let's go back, reread the question, highlight some important information that we can then put into our picture. So a tree casts a shadow of 18 meters. That's important. A person casts a shadow of 3.5 meters. Again, that's important. The height of the person is 1.75 meters. And we want to know what is the height of the tree. Again, that doesn't give us any information, but it's important to know because that's what we're trying to solve. So let's put this information into our pictures. So the shadow of the tree is 18 meters. The person casts a shadow of 3.5 meters. The height of the person is 1.75. And we don't know what the height of the tree is, so we'll put X for that. You can put H, you can put any letter you want, you can put a question mark. The idea is that's what we're looking for. So we need to set up a ratio of these two triangles. So basically we need to set up a division problem of these two triangles. So I'm going to highlight in red the similar sides, or at least one pair. So this is one pair of matching sides. It's both the bottom, it's the shadow of both images. So they're a corresponding pair. And then the heights of the two objects in green, those are corresponding or matching sides as well. So we're going to set up a division problem with these two sides. So let's start off first. We can have, you want to pick a triangle and make sure that all those sides are on top, and then the other triangle will all be on the bottom. So let's say we want to start with the small triangle first. We're going to pick 3.5 meters is the one that I know, divided by 18 meters, because again, those are the matching sides, and that's going to equal 1.75 meters divided by X, or the unknown side. Now, again, we talked about in the last note, if you don't like solving for the variable on the bottom and it does add a little bit of extra work, you can just flip these two sides and it's fine. And make sure that the large triangle sides are on top and the small ones are on the bottom. So actually, let's put that down as kind of a general reminder. Make sure the variable is on top. So in order to do that, we just need to flip both things. So when I flip both of these, this now becomes 18 meters over 3.5. It's still a ratio or still a division of the matching sides. And when I do the other one, X divided by 1.75, again, it's still a division or ratio of the corresponding sides. So nothing's changed in terms of the ratio. It's just now that I have the large triangle on top and the small triangle on the bottom. Now I'm going to solve for X. So now I can work through. It's going to be just 2 steps and I should be done. So because I'm going to rewrite this just so we don't get confused. So 18 meters, 3.5 meters, X divided by 1.75 meters. So after I've done the flip, I want to get X by itself. I'm going to multiply by 1.75 to get rid of, or to cancel these two out. That means I have to multiply the other side by 1.75. X is now by itself. Again, remember m is just a unit, so that can just disappear with a number. 1.75 times 18 gives me 31.5, still divided by 3.5. And then in the end, divide that by 3.5, and you get 9, which is my final answer. So therefore, the tree is 9, and the units were meters. So the tree is 9 meters tall, or 9 meters high. So that's using similar triangles to help us find the height of another object. Example 2, we want to know what is the length of the pond. So again, we're assuming that everything's similar triangles. What I'm going to do is just kind of label the similar triangles because these two triangles aren't in the same kind of orientation or rotation as some of the other examples. So it might be difficult to see which sides are matching. So I'm going to put a green dot for these two because again, for the X patterns, they should be the same. The right angles are already identified, so we know those are the same. So that just leaves these two corner ones as red, so we identify that those are the same. So we want to know what is the length of the pond. So the length of the pond is going to be this spot here with X, because again, that's going across the pond. Maybe just put that this is the pond, just in case we can't tell. So we want to know what is the length of the pond. So again, we're assuming that similar triangles, we can do that. If you refer back to last note, we can see how we can do that with the angles, but we're assuming that it's similar. So we just need to set up a ratio of the missing sides, or of the sides to find the missing side. So we talked about in the last example that we do want to have our X on the top. So let's write that down. We wanted to have it on top. Now what's the corresponding, or what's the matching side in the other triangle that matches up with X? Well, if you can't tell or you're not sure, take a look at the two angles that X is a part of. The right angle, or the square, and the red dot. So if I look on my other triangle, or the small one, I see the red dot and the square. So that means the corresponding, or the matching side to X is 24. And actually, let's just put that and underline it in blue so we know where we got those from. I'll use purple for my other matching side. So I only have two other sides now. I have the one with green dot and the square, it's 6, and the green dot and the square for the other one, it's 10. So now I just need to put them in the right spot. Because X was on top, or the large triangle is on top, that means I'm going to put the 10 on top and 6 will be on the bottom. Because again, you want to make sure that the triangles, or the lengths of the triangles, are on the same side. So the entire bottom here, the 24 and the 6 come from the small triangle, the X and the 10 come from the large triangle. So we're going to now just solve this equation. So I'm just going to rewrite it. So this is just going to look a little bit backwards from the other ones just because we have the X on the left side instead of right. It doesn't matter, you can switch the two sides if you want and flip them, but we'll just leave it here. To get rid of the 24, I'm going to multiply by 24 on both sides. One side divides, one side they cancel out. And I get X equals 240 from the 10 times 24 divided by 6. And when we do 240 divided by 6, we get X is equal to 40. So that means, therefore, the pond is 40 meters long. So again, that's a second example of using similar triangles in more of an application, or finding the height of actual objects. Again, the key thing here is just being able to figure out what your matching sides are and putting them in the right ratio. As long as you have the sides paired up and you set them up properly, you can always flip them around to get the X on the top.